Nearby planet groups. The structure blocks of our enormous area are never again as they used to be. A stunning 771 trillion planetary groups have bafflingly vanished, leaving the scientific community astounded. What follows is completely stunning. From the depths of space, new substances have started to surface, convincing us to reveal the truth behind the unexpected vanishing of 771 trillion nearby planet groups in our huge universe. Might there be an association between the evaporating planetary groups and these perplexing phantoms from the universe? Join us as we embark on a journey through the unfurling astronomical secrets of evaporating stars. North of 771 trillion nearby planet groups have disappeared, and a disrupting peculiarity has arisen from the astronomical void. We will dive into the likely explanations behind the vanishing of nearby planet groups and explore the presence of this baffling infinite peculiarity. Mankind has spent thousands of years understanding concepts like science and mathematics, which help us grasp our place in the universe and the essential idea of Earth. Despite the fact that the center remains a secret, one crucial idea is that matter doesn't simply vanish. It changes. Similarly, when a star detonates and vanishes, its material disperses across the universe, persisting in a different form. This raises a captivating secret in space. The evaporating stars from our night sky might not seem especially astonishing given the immensity of the universe. Stars can evaporate out of nowhere for different reasons, like reaching the end of their life or getting pulled into a huge substance like a black hole. However, what makes the situation baffling is that it's not only a few stars vanishing. There are endless stars, over 700 trillion, that have bafflingly disappeared, leaving cosmologists bewildered about how they could have blinked out of existence so suddenly. While a few vanishing stars can be explained in a universe as vast as ours, the disappearing of many trillions, particularly those that aren't approaching the end of their life cycles or threatened by external forces, presents a totally unique issue. Luckily, a group of dedicated researchers is eagerly attempting to unravel the secrets of the universe. Beatrick Volume 50 from the Nordic Foundation for Theoretical Physics in Sweden sheds light on their endeavors, explaining that their task, known as VASCO, is a huge undertaking. Their primary goal is identifying a star that has remained a consistent presence in the night sky for as long as human memory and available records can recall, only to evaporate suddenly without a trace. Even the most advanced telescopes have failed to identify any remnants of such stars. Estate Roll highlights that this isn't simply a capricious pursuit. The VASCO project has been active since 2017 and has earned extensive attention. The team is driven by their intense motivation to participate. The group acknowledges that certain aspects of the universe remain erratic due to immense distances, making it challenging to catalog each celestial object with absolute accuracy. Nonetheless, they maintain their trust in the capability of finding a particular type of star unexpectedly evaporating from the night sky, a peculiarity that has not been reported before. Manner R underscores that while variable stars exist, their changes usually happen over several years. The mission is to find a star that changes from steady visibility to complete vanishing, a discovery that could potentially open new realms in the domain of physics. You may be wondering if it is truly possible for a star to vanish without warning. The answer is yes. For instance, there was a star that astronomers closely monitored for an extended period, spanning 20 years. Until 2019, this star drew their interest partly due to its remarkable blue brilliance. Then, abruptly, it disappeared from their observations. Andrew Allen, a doctoral student working in astronomy at Trinity College Dublin, carefully analyzed and reconsidered the data. The prevailing hypothesis suggested that the star had undergone a supernova explosion, transforming into a black hole. However, there were no detectable signs of a supernova event or the expected black hole. Additionally, there was no visible black hole. Given the delay between observations, it seemed highly unlikely that such a dramatic event could have gone unnoticed. If indeed the star had transformed into a black hole without any supernova activity, it represents a case of vanishing without the usual dramatic display, a peculiarity that has left astronomers seeking answers for an extended period. Hints pointing to such events date back to 2009 when a star, which had garnered attention from various telescopes, appeared to be approaching a peak. This star underwent an unexpected transformation into a black hole before researchers could fully grasp the intricacies of the process. While substantial evidence remains elusive, this event left astronomers puzzled. Similarly significant is the collaborative effort of numerous research groups, including those mentioned earlier, in compiling comprehensive star catalogs and their attributes. These catalogs enable astronomers to access star data online and conduct extensive investigations. The findings have been both encouraging and astonishing. As one researcher noted, they have identified several short-lived wanderers that briefly appear in one image before vanishing, comprising most of their discoveries thus far. However, there are also various peculiarities that defy immediate categorization. An assessment of some of these brief trends ruled out possible explanations like M-dwarf flares or nova events. Building on this, a prevailing theory among some space experts is that the vanishing of these stars might be related to how light travels across the vast expanse of the universe. Imagine having a light source in your room and then leaving it until it evaporates. Now, extend this concept across galaxies. This raises the essential question of how we can see anything at all. The answer lies in the fact that the endless light beams radiated by these stars take an extraordinarily long time to reach us. Even when they eventually arrive, they mix with the light from our sun, enhancing their visibility in our night sky. In reality, the light we see is often millions of years old. For instance, light from our sun, which is relatively close, takes approximately 8 minutes to reach Earth. When we apply this to stars located light-years away, the age of the light we see becomes strikingly apparent. This seemingly rapid vanishing of stars might be a result of the immense age of the light we observe. Although it appears instantaneous to us, the star could have ceased to exist a long time ago, and we are only now noticing its absence. This also aligns with the idea of stars undergoing extended periods of brilliance followed by fading until they reach a point where they are no longer distinguishable. It's a complex concept, and while challenging, these questions need to be raised to uncover the truth behind these phenomena. Some researchers are drawn to investigating Dyson spheres and similar extraordinary possibilities. Among these hypotheses, one notable theory concerning evaporating stars involves considering the role of extraterrestrial beings. You might wonder how extraterrestrial beings could cause stars to vanish. The answer doesn't lie in making stars disappear, but rather in the intriguing possibility that these massive celestial giants might be utilized for their purposes. Have you ever encountered the concept of a Dyson sphere? While it currently resides in the realm of science fiction, it envisions a scenario where advanced extraterrestrial civilizations, or even hypothetical future events on Earth, involve constructing a specific megastructure orbiting a star. This superstructure serves as a means to capture and harness the star's energy on a massive scale, effectively transforming the star into a colossal energy source or even a formidable weapon. This idea bears resemblance to the scenario depicted in Star Wars: The Force Awakens, where the Star Killer base harnessed a star's energy to destroy several planets of the Republic. However, the feasibility of such an explanation faces significant obstacles. First and foremost, the existence of extraterrestrial life remains unconfirmed. Moreover, the construction of a fully functional Dyson sphere, even around a relatively modest star, would require a tremendous amount of time and a level of technological sophistication that surpasses our current capabilities. Applying this concept across more than 700 trillion stars becomes an enormous cosmic undertaking with questionable likelihood. Nonetheless, this idea of the great nothing still retains its proponents. So where does this leave us? The answer is that we are left without definitive answers. What we can be sure of is that something extraordinary is unfolding in the universe, leading to the vanishing of stars from our observations and perceptions. This cannot be dismissed as a random occurrence, as we have observed the noticeable absence of various stars. The central question that remains is, what is causing so many stars to evaporate within a relatively short period of time? This is precisely why individuals and organizations from diverse disciplines are focused on unraveling this mystery. Finding answers to these questions might provide us with a deeper understanding of the universe. If similar phenomena arise in the future, we might be better prepared to quickly interpret their causes. While the mystery of star vanishing continues to confound us, something novel has recently emerged from the depths of the universe. Researchers have recently serendipitously discovered enormous voids in space that surpass our initial expectations. These voids include scales stretching from the solar system to the Milky Way. The universe is characterized by such gaps, sweeping regions where celestial phenomena are notably intriguing. Among these, one remarkable void stands out, the Boötes Void, often referred to as the Great Nothing. When you look toward the night sky, it often appears as an immense, evenly dispersed array of stars. However, in specific regions like the Boötes Void, things are quite different. These regions contain very few celestial objects. Essentially, the universe has an extraordinary structure. Long strings of dark matter winding through galaxies and groups of galaxies with enormous voids in between. The Boötes Void has a diameter of about 330 million light-years, located near the Boötes constellation and about 700 million light-years from us. Initially, this void had only one galaxy, but since its discovery, we have found a few dozen more. The average distance between these galaxies is around 10 million light-years, which is multiple times greater than the distance between. The impact of dark energy on cosmic voids. The accelerated expansion of the universe, driven by dark energy, is less noticeable within stars, galaxies, or solar systems due to the overpowering influence of gravity. This means that while dark energy's effects are masked by gravitational forces in these densely packed areas, they become more apparent in vast, empty cosmic voids. These regions, being sparsely populated, are more susceptible to the universe's accelerated expansion. As a result, the size and scope of these voids can grow significantly over time, providing evidence of dark energy's influence. Cosmic voids and the future of astronomy. The study of cosmic voids has led to some intriguing possibilities and future research directions. By analyzing these voids, scientists hope to gain deeper insights into the nature of dark energy and the overall structure of the universe. Understanding these voids may help answer fundamental questions about cosmic evolution, the fate of the universe, and the forces shaping it. The Boötes Void, an exceptional case. The Boötes Void stands out as one of the most remarkable examples of such voids. With a diameter of approximately 330 million light-years, it is one of the largest known voids. Its sheer size and scarcity of galaxies have prompted researchers to investigate its formation and implications. The Boötes Void highlights the complexity of cosmic structures and the limits of our current understanding. Recent discoveries and technological advances. Recent advancements in technology and observational methods have allowed astronomers to explore these cosmic voids with greater precision. Instruments like the Hubble Space Telescope and various space-based surveys have provided valuable data, helping researchers map these vast regions and understand their properties. Conclusion: unraveling the mysteries. As astronomers continue to explore and study these cosmic voids, they are not only uncovering new aspects of the universe's structure, but also challenging existing theories and models. The ongoing research into cosmic voids, dark energy, and the large-scale structure of the universe promises to reveal more about the fundamental forces shaping our cosmos. While many questions remain, each discovery brings us closer to understanding the true nature of the universe and our place within it.